In this video, we're going to do the second example in the titration lesson. So here we have an actual titration that we're trying to figure out. We're trying to figure out the concentration of something unknown right now. We have 0.2 mole per liter NaOH used to titrate some HCl. So we don't know the concentration of the HCl. We know when the end point was reached, when 10 mils of the NaOH was added. Calculate the concentration of HCl. So first of all, let's go ahead and write our equation out. So we have our NaOH. We're adding that to some HCl of unknown concentration. And when they do react, this is a strong base, strong acid. We're going to get close to a pH of 7. But we should get, and that's assuming they react perfectly. If you don't have any excess or any limiting, of course, because if you have excess, you neutralize, but then you add more of the base or the acid or whatever it is. So that's going to make a salt, NaCl, AQ, plus H2O. And you need to make sure it's balanced, and it looks balanced to me right now. So just to show you what this looks like, this would be kind of like this. So we have our flask over here. Okay. And we have 25 milliliters of HCl in here. We don't know the concentration. Okay, so we have our volume is 25 mils, which I'm going to put into liters, 0.025 liters. And we're looking for concentration. Remember, concentration is N over V. So we have volume already, but we need number of moles. We'll figure that out in a second. And then we have our burette. Our burette contains the base that we know the concentration of. Oops. So this is our burette over here. And in here, I have 0.20 molar NaOH. And it says that basically my color changed once I added 10 mils of the NaOH. So for example, I might have started at, let's say this was 0.00, except here, I don't know why we're not using more sig figs. We should if we used a burette, but let's just say we weren't very accurate with it. I started at 0, and then my meniscus reached the number 10 here. So 10 minus 0, I added 10 milliliters, or it might have started at 2 and went to 12. 12 minus 2 is 10 milliliters. So either way, I essentially had to add 10 milliliters of the NaOH to the HCl before the color changed. So 10 mils of the NaOH was required. So that's 10 milliliters, which is approximately 0.01 liters. And the other thing I know about my NaOH is the concentration. So I know the concentration was 0.20 moles per liter. So a little reminder, concentration is equal to N over V. Essentially, I could figure out how many moles of NaOH I have, because moles is C times V. And then I could use my moles of NaOH to figure out how many moles of HCl must have been there through stoichiometry. And then I can find my concentration of my HCl. And that's how a titration works. If you have something known, you figure out how many moles of that known stuff you must have used, do a titration, do a stoichiometry problem, and figure out your concentration of the stuff you didn't know. So this is step 2 here. Let's figure out the number of moles of NaOH. So it's going to be equal to 0.20 moles per liter times 0.01 liters. Cancel out liters. So you get 0.002 moles. That's how many moles of NaOH you must have used. So now let's do a mole ratio. Since we have a 1-to-1 ratio of NaOH to HCl, the moles of NaOH are equal to the moles of HCl, which is the 0.002 moles. Now our step 4 is to do the C is equal to N over V, because we want to figure out the concentration of the HCl here. So we have 0.002 moles divided by our volume of the HCl, 0.025 liters. We're not adding the volumes up here because we're just saying this is the volume of HCl we had there to begin with. So this is how many moles of HCl we have in that volume. So we want to figure out what the concentration of the acid is before mixing and all that. So we have our 0.002 divided by 0.025, and we get about 0.08 moles per liter. And that seems to be to 1 sig fig, which is what we needed. So we can say, therefore, the concentration of HCl is approximately 0.08 moles per liter. Now, assuming if there was no excess or no limiting, the pH at equivalence point should be about 7 for the entire mixture. But you could find the pH of your HCl solution in here now, because you know that the concentration of HCl is 0.08, so you could do your ionization equation, find the H+, and do your negative log of H3O+. So you can carry that through if you wanted to find the pH of that solution as an extension to this as well. But that was our first titration style question. It wasn't quite as extensive because we gave you like let's assume this was the average volume. But in reality, in a real experiment, you would do 3 trials and use the average volume in your calculation like this here. So that was a titration style question. We found the unknown concentration of the HCl using NaOH with known concentration to get to the end point. And remember, the end point is not quite the equivalence point. It's close to it, though. It's where the color change happens, but it happens in that steep region of the titration curve. So the steep region over here, for example, is roughly where it would happen at. So close to a equivalence point of pH is equal to 7. Because remember, this is a strong base, strong acid, should be close to 7. So color change happens near there.